Welcome back to the DSA solutions. Today's question is to delete node from binary search tree. Let's divide this question into two parts. So first get the node you want to delete, then delete the node. Search a node you are going to delete. Start from root node and check if given key is greater than the root node value. Then search in right subtree of root node. Else search in left subtree of root node. Search 95 to delete. Once you find 95, let's track the parent node of this node. 90 is parent node. Tree node reference variable, we took current node to traverse the tree, parent node to track the parent of node to delete, and is left child is to track node you are going to delete is itself left child or not. Searching a node, let's check if given tree root is null or not. If it is null, then return null. Now search node while current is not null. When current node is not null and value is not matching with current node value, then check if given key is greater than the current node value, then move current node to right side, else move to left side. So while moving to left side, make flag is true, that means left, that current node is now left child. So yeah, at the end, if key not found, then return root node. Now we got all the details, like a node you are going to delete that you got, and parent node and is left child flag you got. So here we have three scenario to write a code. Let's understand the first scenario. First scenario is the node you are going to delete is left node. That means node is having no children, left children and right children is not having. So you see the first diagram, 60 is to delete. So then set parent node left is null. And second diagram, 95 to delete. Then set parent node right to null. Here we are making a decision, left child or right child, to make a null by using is left child. If is left child is true, then we are making parent node left is null. If is left child is false, then we are making parent right is null. The node which want to delete, let's assign this with tree node reference delete node for better understanding. Now check if delete node is left node or not. If mean left node and right node is null, then check delete node is root. If it is root, then return null. Else if delete node is left child, then make parent node left is null. Else make parent node right is null. The node you are going to delete has one right child. 50 to delete, 50 is root. Set root is delete node right. Next, here delete 5. 5 is left child. Then set parent node left to delete node right. Next, delete 20. 20 is right child. Then set parent node right to delete node right. The node you are going to delete has one left child. 10 to delete, 10 is root, so set root as delete node left. Here delete 5, 5 is left child, so set parent left to delete left, delete node left. Next delete 20, 20 is a right child, so set parent node right to delete node left. scenario, node we are going to delete has left child as well as right child. So we will first identify the successor of node to delete. The successor will take node to delete place so that the tree structure will be balanced. Next point, to know what is successor and how to get the successor. So successor is the smallest node in the right subtree of the node you are going to delete. In this case 5 is the node you are going to delete, and if you check right subtree of 5, 7 is the lowest node. So just keep the 7 node in place of 5. Next you see this tree will be our final output tree. So here 30 is to delete, successor is 40. So first set parent node left to successor, then successor left to delete node left. Next 90 is to delete, then successor is 95. So first set parent node right to successor, then successor left to delete node left. So here in both scenario we have one common statement, that successor left is pointing to delete node left. Another point to note, delete node, if delete node is left child, then we are pointing parent left child to successor, else parent right to successor. Successor node from get successor method, we will implement this method in later section. So we got here the successor. Now you check, if delete node is root, then set root to successor, else check delete node is left child, then set parent left to successor, else set parent right to successor. After that set successor left to delete node left. Modification of all this, we will be returning root node. Time we have explained where successor was right child. This time we have the successor is left child. So I will implement the get successor method now. There I will add this scenario. So let's understand this. 32 delete, you got the successor 35. Let's track parent successor as well. So this is 40. Set parent successor left to successor right, and set successor right to delete node right, and this is the tree you will get as a successor. So we'll be returning this one. Next, now we got this tree as delete node is left child. So set parent node left to successor and set successor left to delete node left. So these two statement we already written while calling get successor method. Will be not writing again. Parent successor to track the parent of successor node, and current node to traverse the right subtree of delete node. So initially we assigned current node to right of delete node. So while current not null, move current to left side and get the successor. At the end, if a successor is found, that is left child, then set parent successor left to successor right, and set successor right to delete node right, then return the successor. This is the code for your reference. So if this video is really helpful to you, like this video. Thank you guys.